All right. How many household cats hunt birds? Domestic cats kill more wild birds in the United States than scientists thought, recent article states. And we could look up that in the book if we wanted. Researchers use a sample of n equals 140 households in the US with cats to estimate that 35% of household cats in the US hunt outdoors. And we're asked to find and interpret a 95% confidence interval for this proportion. Is it plausible that the proportion of household cats in the US hunting outdoors is 45%? Is it plausible that it's 30%? All right, let's take a peek. So I just want to back up and think, all right, what's the population here? Well, we got the United States coming up over and over again, and we're looking at, I guess, US cats. So population, and the reason I'm talking about the population here is in order to make a good interpretation, to state what these numbers mean, you got to know what your population is, you got to know what your parameter is. If you don't know those, then your interpretation is crap, and we don't want to write crap. So population I'm taking is US household cats. US household cats. So population is some big group out there. That's the big group. I got 3 of them at home. Proportion. All right, so I got to reread this to think about what that is. Domestic cats kill more wild birds in the US than scientists thought. Recent article, blah, blah, blah. US with cats to estimate household cats in the US that hunt outdoors. Yeah. All right, so my proportion is proportion of US household cats who hunt outdoors. And I have a sample of 3. One cat doesn't care, the other cat's too fat, and the other's only a year old and thinks birds are the tastiest.
I think we would, yeah, I was gonna say, I think we need to make sure we kind of emphasize that they're household cats, right? Like, so people don't know that they're, you know,
as opposed to feral cats, right? Stray cats, and then other cats out there that live in the US. Yeah, so household cats, definitely got to put that in there. So that's important. All right, so then we have this sample. Sample, 140 household cats. That's the sample. Statistic. Would be the proportion in this sample that hunt outdoors. Again, I got to do this so that I can write a good interpretation. So I got to get that step in my head. And we don't know what the real proportion is, but we do know what the sample proportion is. So that's our p hat, and we're given that that's 35%. Okay. Now, as far as the confidence interval goes, we can go straight to the margin of error because we have this new formula. So the margin of error is going to be the z-score needed to get the correct confidence level. And we've done that plenty of times. That's about 1.96 times our funky square root, p hat in the numerator times 1 minus p hat divided by n. So let's see, square root. So we've got 35% as a decimal, 0.35. And then 1 minus that is going to be 0.65. Divided by 140. So that's going to be the margin of error. We know this is the point estimate in the middle, so we need the margin of error to figure out how far to the right, how far to the left we need to go for our interval. And I think this is a good place to use a spreadsheet. So I'm going to start a spreadsheet and share it out. And I already started one. This one right here. So let's share this to the live individuals and people in the future on YouTube. Copy and paste. And I'm going to continue to add to this spreadsheet, so I'll use it next class when I'm doing means. And I'm going to use it for hypothesis tests too. All right, so we got that. And I already, I set up how I would do it for the Umatilla County, the 9 out of 40, the first one I did. So I'm just going to repeat how to make all these calculations in a spreadsheet on the new tab. So I'm going to start a new tab here. Cats, kill birds. And I'm just going to pull a title at the top, percent of US household cats that hunts. And often I want to know what X is. So X would be the actual number of cats. I don't have that yet. I have N. So usually we have these things that are given to us, and then usually the confidence level is given to. So as far as my X here, I can calculate that based on N. So I'm given for sure N is 140. And so don't make a copy of this yet, because I'm still building it, but feel free to, or you can make a copy and then get another copy later. To get my X here, that would be 0.35 times the 140 below. So that would be 49 out of 140 ends up being that 35%. Confidence level, I'm going to put that in as a decimal, 0.95, 95% confidence level. All right, from there, I want to either type in p hat before. So either you're given that, like I was given the 0.35, or you have to calculate it because you were given a number and that happened and then the sample size. So in this case, I could say, let's take 49 and divide by 140, and that should give me my 35%. I like to calculate the 1 minus p hat up front instead of writing 1 minus in my formula. I find to make less errors that way. So 1 minus, and then click on the number, click on the number. All right, see what I put next. Add a method to my madness. So at this point, I'm ready to find the standard error. And the standard error is that square root formula. On a spreadsheet, it's SQRT, finds the positive square root of a number. And then I just take my p hat times, I already calculated 1 minus p hat, and then slash to divide by the sample size. And so I'm getting a standard error of about 0.04. In this case, that would be interpreted as about 4% compared to the 35%. All right, so I was grouping those together, and then to get the z-score, I need to know about the tail. So I just want to draw a quick sketch of what I'm doing here, just to remind you. So a lot of times when I'm calculating confidence interval or running a hypothesis test, I draw the normal distribution. Since this is a confidence interval, I put p hat in the middle. And I'm running a confidence interval where I have 95% in the middle. Alpha is always 1 minus that. And that's what the tails get to share. Oops, I'm getting ahead of myself. 5%. So each tail gets alpha over 2. So alpha over 2 would be that 5% divided by 2, which is 2.5%. Right, so that's what goes into the tail here. And the reason I'm getting that is I need that to get the right Z star on a spreadsheet. StatKey has that Z score calculator, that normal distribution calculator, but I want to get it here too. So I want alpha, oops, I'm not in the right spot, alpha. So that's just 1 minus my confidence level. And nice thing about doing it this way is if somebody says, no, 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 the sample size was 40, or the number of favorable number of cats was 48, I can just type it here and it'll recalculate. Or if somebody says, do you want a 98% confidence interval? I just put 0.98 and it recalculates stuff for me here. Building a spreadsheet that's reusable. So I don't have to do this all the time. Over 2. Just take that number above, divide by 2, and this could all be done with less cells, but then that, I think, leaves more room forever. So now I'm ready to find my special z-score. And I went over this last week. To get a special z-score, that's called an inverse normal, because we're given the tail probability, we want to know what the z-score is. And it takes a little practice remembering that. So I start typing normal. I want the norm dot inverse. In some of my videos, I do the norm inverse. They behave the same. The difference is Excel doesn't have norm inverse anymore. They just have norm dot inverse. So that's more for compatibility with Excel. And then in this case, it says X. What is X? X is the left tail probability. I talked about that last class. So that's my left tail probability. And this is a z-score, which means the mean is 0 and the standard deviation is 1. And I'll write that down separate in a second. And it's going to always report it back as a negative number, so I'm just going to sneak a negative in front to make it positive. Oops. So there's my z-score, which is about 1.96. All right, so then I'm ready to do the margin of error. And the margin of error is just your z-score times your standard error. And here I just got a lot more decimal places than StatQ provides. Is it more accurate? The answer is yes and no. This is theoretical, like saying the probability of getting ahead when you flip a coin is 1/2. And then now I can get the lower and the upper. So the lower is always your point estimate, that's my p hat, minus the margin of error. And the upper, no thank you, I don't want to autofill, is your point estimate, p hat. So we think the proportion is about 35%, but we could be off. How far off? Well, we could be about 8% off, plus that margin of error. Right, 0.079, that's almost 8%. So these are the values I got. That's probably more decimal places than we need. So let's take that down to maybe 3 or 4 decimal places. Let's go 4 decimal places. All right, so we have a margin of error that's 7.9% there. We have a lower 27.1% and an upper of 42.9%. So that is our confidence interval based on the central limit theorem. So 27.1, 42.9. So back here, we think that p hat is 35%. We think the lower is 27.1%. And the upper, I messed that up, 42.9%. So this is our confidence interval right there. So we can either say for our confidence interval that it is 35%, 0.35, plus or minus our margin of error, that was 7.9%, 0.79. Or we could state it as an interval, which would be that 0.271 up to 42.9%, 0.429. And now we go to interpret it. So what's the interpretation looks like? So the interpretation wouldn't be saying, hey, the confidence interval is this. That doesn't help. We need to include what the parameter means. And so that's why I did this prep work about thinking, what am I measuring here again? So interpretation. This would be, we are 95% confident that the proportion of household cats, I'm thinking about what I wrote down before, in the US hunt is between, and in the interpretation, I'll state it as a percent instead of a decimal, 27.1% and 42.9%, period. All right, and this problem went on to add a couple of other questions. Let's see, where did I put that back here? So we found the confidence interval, we interpreted it. Is it plausible that the percent is actually 45%? Well, 45% is not in the interval, so I'm going to say no, I don't think that's likely. Is it possible? Yeah, but I think it's unlikely because it's not in the interval. The central limit theorem says that about 2.5% of other possible samples of 140 cats would have a proportion that's higher than 42.9%. Okay. Where does 45 live in that interval? Let's see, 45 is probably around right here. What's the other question? The other question was, is 30%? Oops, back here, too many pages. Is it plausible that it's 30%? Yeah, 30% inside my interval. So 30%, see, that's 27, 30% is probably right about here. So yeah, I would say, yeah, it's plausible that it could be 30%. I don't think it's plausible that 45%, because that's not in my 95% confidence interval. Is it possible? Yeah. Is it likely? No, I don't think so. So what I want to do next on this is run a hypothesis test on this 45 to see how unlikely that 45 is. So let's do that. Yeah, I know when I put the P with the hat, I want to read it as fat. Okay, so next.